Hello guys, welcome to this lesson. My name once again is Henry. Today I want to walk us through logarithmic expressions, taking an example to trace the laws of logarithms we looked at in the previous lesson. This example will walk us through how we can apply a number of these laws in resolving logarithmic expressions in such a way that we are able to come up with a solution. I will walk us through the screen so we can have a perspective on this. Here you can see right here on the screen an expression, which of course is a logarithmic expression. And this expression here, you have logarithm of 8 in base 2 plus logarithm of 4 in base 2 as well. For us to resolve this logarithmic expression, we'll need to first recall one of the basic laws I did mention in a previous lesson, where I talked about how we can decompose the logarithm of a product in such a way that we are able to add up the individual logarithms of these products. Let's say, like we had in our previous lesson, the law logarithm, multiplication of product rule, where we have logarithm of, say, P times Q in base A, in base A, yes. So let's have that in base A. Okay. So we have this logarithm. Let me put that in brackets if you have to do that, so we don't get it all mixed up. So I need to take this off so we can be able to do what we need to do here. Okay, so where we have that, that is logarithm of PQ. In other words, we are taking the logarithm of this product. Now, we said in our previous lesson that this will result in the individual logarithms in the same base, this time log P in base A, okay, in base A, plus logarithm of Q, Q also in base A. So let's put up the base there so we get it clear. Now here you have the product of PQ. We take the logarithm in base A. Remember this law of logarithm, I explained this in our last lesson, that if you take the logarithm of a product, in this case PQ, to a particular base A, you can decompose it into the respective logarithms of these individual numbers, taking the logarithm and adding them up respectively. Now, when you look at the logarithmic expression we have here, you can see that the right-hand side of this law fits properly into the expression we have here, which we are going to resolve. So this expression can be condensed to look like what we have here on the left-hand side of the law, this logarithmic law. So it therefore follows that where we have logarithm of 8 base 2 plus logarithm of 4 base 2, we can condense it, just like we moved from this left-hand side to the right-hand side here. So we're going to move this to look like what we have on the left-hand side of this law of logarithm. So this becomes the logarithm of 8 times 4. In this case, it will be times 4, all right, in base 2, because the expression is given to us in base 2. So we'll put it in base 2. So you can see that what we have done is to condense this to this form, which is what you see on the left-hand side of this law of logarithm. So taking this further, it becomes logarithm 8 times 4 gives us 32. That's in base 2. Right, that's in base 2. Now we have this condensed into a form where we can now proceed in applying another law. So what we'll do from this point is to transpose this into an index form. Recall our other law of logarithm, where we said if you take the logarithm of an index number, P, say to the power of Q, okay, let's say P, say to the power of Q, right, let me put it, say P to the power of Q in base A, when you have this, remember what we said in our last lesson, this is expressed as the index multiplied by the logarithm of the number, in this case, the logarithm of P, base A. All right. So now you can see that what we have here is expressed in this form. So when you take the logarithm of an index, we normally express it this way. Now that we have the logarithm of 32 base 2, let's transpose it into an index form so we can apply this law of logarithm and put it in this form where it will be easy for us to work out what we need to see. So logarithm of 32 can be said to be equivalent to the logarithm of 2 to the power of 5 in base 2. It is equivalent to the logarithm of 2 to the power of 5 in base 2. Okay, now what do we have here? Let's go back. Where you have logarithm of 32 base 2, it's being transposed to look as an index form, just as you can see there on the screen. 2 to the power 5 is 32, in which case 2 to the power 5 is 2 times 2 in 5 places, and that gives you 32. 2 in 5 places gives you 32. So we've been able to bring it into an index form, which follows that we will express this as what we have here on the right-hand side. So this will now be 5 multiplied by the logarithm of 2 to base 2. So that will be multiplied by the logarithm of 2 to base 2. So let's fix the base here. So this is what you have. Now, just to quickly point something out to us, there is a law of logarithm that says the logarithm of a number to the same base will produce 1. For example, the logarithm of 100 to base 100 is 1. The logarithm of 1 million to base 1 million is 1. The logarithm of a to base a is 1. Similarly, the logarithm of 2 to base 2 will give us 1, which follows that our expression here on the right-hand side becomes 5 times, so 5 times 1. So how is it 1? That's just what I mentioned earlier on. The logarithm of a number to the same base is 1. So the logarithm of 2 to base 2 is 1. So this becomes 5 times 1. That gives us 5. Now we've been able to resolve this logarithmic expression, and we have our solution, which is 5. So this is what you have. This is a basic application of the laws of logarithm. And you can see clearly from here that that's what we have. If you have any question, feel free to drop the question in our chat window. This will be the end of it. In our next lesson, hopefully, we'll talk about how we could apply these laws of logarithms to logarithmic equation. Until then, I'll see you in the next lesson.